Our Earth was born from a cloud of dust and space particles around 4.5 billion years ago. That's a really, really long time ago. During this long existence, the Earth's climate has changed many times. There have been periods when the Earth has been covered in ice over a kilometer thick, and there have been times when the Earth has been much warmer than it is today. Over the last 650,000 years, the Earth's global temperature has gone up and down in a regular pattern. Scientists have linked these cycles in our Earth's climate to several factors, including changes in solar radiation, changes in atmospheric turbidity, and changes in radiation-absorbing atmospheric gases. In addition to factors that change Earth's temperature globally, phenomena such as changes in the Earth's orbit and changes in the Earth's surface affect climates locally. Just as the Earth experiences periodic changes, so does the Sun. And these changes in the Sun can lead to climate changes on Earth. A sunspot is, just like it sounds, a dark spot that sometimes appears on the Sun's surface. Sunspots are the result of concentrations of the Sun's magnetic field. This results in cooler surface temperatures and thus a darker color. The increased magnetic activity of sunspots lead to greater solar radiation hitting the surface of our planet. Thus, high sunspot activity is associated with warmer climates on the surface of the Earth. As an example, the Maunder minimum was a period from about 1645 to 1715 where very few sunspots were seen. Scientists theorize that this lack of sunspot activity is linked to the coldest period of the Little Ice Age, which lasted from around 1300 to 1870. Atmospheric turbidity refers to the amount of tiny particles, such as water droplets, dust, and smog, suspended in the air. Increased turbidity scatters the sun's rays. This makes it harder to see, but it also means that less direct solar radiation is hitting the Earth. These tiny liquid or solid particles suspended in the atmosphere are also referred to as aerosols. Aerosols reflect incoming solar radiation, bouncing it back into space. As a result, less radiation makes it to the Earth's surface. So, an increase in atmospheric aerosols creates a cooling effect on the planet. If you look at this diagram, periods of high dust concentration in the atmosphere, that's the red graph at the bottom, coincide with lower global temperatures, the blue graph on top. Certain gases in our atmosphere allow the radiation from the sun to pass straight through to Earth's surface. Some of this radiation is then bounced back off the planet. However, this time, since the Earth is nowhere near as warm as the sun, the radiation is less intense with a longer wavelength. These same gases that just let the sun's radiation through now reflect the longer wavelength radiation back to Earth, trapping the warmth within the atmosphere. This is known as the natural greenhouse effect, the warming of the Earth's surface and atmosphere through the trapped energy of the sun. These natural greenhouse gases include water vapor, carbon dioxide, and methane. The gases in the atmosphere are serving the same purpose as greenhouse gas. They are letting in the sun's warmth and trapping it inside, so the greenhouse, our planet, heats up. The greenhouse effect is a good thing. Without it, our planet would be a cold and inhospitable place. The greenhouse gases go through a natural cycle that coincide with the warming and cooling of our planet. We hear so much about greenhouse gases in the news lately because, through factories, cars, and the burning of fossil fuels, humans are dumping many more greenhouse gases into the atmosphere than can be considered natural. Because of this, our planet is heating up much quicker than would otherwise be expected. Other climate-changing factors do not necessarily affect the temperature of the entire planet. Nonetheless, these factors can cause significant changes in individual regions. As I'm sure you remember from grade school, the Earth rotates on its own axis. At the same time that it is rotating, it also orbits the sun. While you may expect Earth's rotation and orbit to always remain the same, it actually doesn't. Remember, the Earth is very, very old and has gone through many changes in its long life. The Earth's obliquity refers to the angle of Earth's tilt on its rotational axis. Currently, the Earth is tilted at 23.4 degrees from straight up and down. Over a time period of 41,000 years, this angle travels from 22 degrees to 24.5 degrees. This change in tilt affects the climates of particular regions on the planet. The areas that begin to receive more direct sunlight as the Earth tilts will become warmer. The areas that start receiving less direct sunlight will cool down. Eccentricity refers to the shape of the Earth's orbit around the Sun. Over a period of approximately 100,000 years, our Earth's orbit changes from almost circular to highly elliptical. Currently, our orbit is quite circular. When the Earth's orbit is very elliptical, either the northern or southern hemisphere boils in extremely hot summers and freezes in severely cold winters. The opposite hemisphere basks in warm summers and mild winters. And finally, due to the gravitational pull of other bodies in the solar system, particularly the Sun, the Moon, and Jupiter, the Earth undergoes a phenomenon known as precession, or the wobbling of the Earth as it spins on its axis. Similar to a spinning top, the Earth appears to sway as it spins on its axis. Again, this wobbling effect does not alter the climate of the entire planet. It does, however, affect individual regions by making summers and winters in some areas longer and more severe. At the same time, other areas are blessed with summers and winters that are shorter and milder. Earth has developed since its birth 4.5 billion years ago, and it looks very different today. The outer surface of the planet, known as the lithosphere, is made up of the crust and upper section of the mantle. The lithosphere consists of 12 plates that are constantly shifting and moving past each other. As the land masses on top of these plates change positions, they interrupt surface ocean circulation, redirecting the circulation of warm and cold water as a result. Water temperature has a huge influence on the local climate. Florida is infamous for its hot, humid summers. These summers are caused, in part, by the warm waters from the equator flowing up and through the Gulf of Mexico. Thus, as the plates move and interrupt the warm and cold water currents, local climates will change in response. As the lithospheric plates collide into one another, they create mountain ranges. North-south oriented mountain ranges in particular interrupt atmospheric circulation, again redirecting the circulation of warm and cold air. Just as local water temperature affects regional climates, so does air temperature. As land masses shift and modify the warm and cool air currents, the nearby climates will adjust accordingly. So let's summarize. Our Earth has gone through many predictable periods of cooling and warming in its long history. Scientists have linked these climate cycles to various observable factors. Changes in solar radiation are caused by sunspot activity. An increase in sunspot activity leads to greater radiation hitting the Earth and is thus associated with warmer climates. Atmospheric turbidity refers to the amount of tiny particles, such as water droplets, dust, and smog, suspended in the air. These tiny particles, also referred to as aerosols, reflect the sun's radiation back into space and thus have a cooling effect on the planet's surface. The natural greenhouse effect is the warming of the Earth's surface and atmosphere through the trapped energy of the sun. The natural greenhouse gases include water vapor, carbon dioxide, and methane. Greenhouse gases go through a predictable cycle that coincides with the warming and cooling of our planet. Changes in Earth's orbit include obliquity, eccentricity, and precession. These changes do not alter the Earth's temperature overall. Rather, they create more localized climate changes, affecting only particular regions of the planet. Obliquity refers to the angle of Earth's tilt on its rotational axis. Eccentricity refers to the shape of the Earth's orbit around the Sun. Precession is the wobbling of the Earth as it spins on our axis. Our planet's lithosphere is broken into 12 plates that are constantly moving past each other. As the physical characteristics of the Earth's surface change, the circulation of warm and cool air and water is shifted, and local climates are affected as a result.